Continuing on with the geometry ideas of Unit 7, we're going to be talking about triangles some more. And this time in 7.2, the I can statement is I can solve problems using the exterior angle theorem. Exterior angle theorem. Again, like we mentioned yesterday, got another vocabulary in geometry. It can sound horrible, but if you know what the geometry is, it turns out to be pretty easy. So in the warm-up it says, what do the following words mean? So interior, exterior, and remote. So think about those for just a second. If we say the interior of your house, we're talking about inside. So interior is a fancy word for inside. Exterior then is a fancy word for outside. And remote. Remote maybe is a little bit difficult. We're not talking about the remote that you use to turn your TV on and off or change channels or things like that. We're talking about a different type of remote. We're talking about maybe camping in a remote place, or somebody was found in a really remote area or something like that. When something is remote, it's away from everything else. Okay, so we're going to say away from. All right, remote means away from. So I guess you could say you can control your TV with your remote when you're away from the TV. You don't actually have to touch the TV, which, back in the day, you had to get up and change the channel. So anyway, let's talk about what the exterior angle theorem says, and then we'll try and figure out why this theorem works the way it does. So the exterior angle theorem is this. Remember, a theorem is an idea that's proven to be true, and we'll do a quick little proof or a quick little idea of why it would be true. So it says the measure of a blank angle of a triangle is equal to. So the word that's going to go here is the measure of an exterior angle. Exterior angle of a triangle is equal to the sum, S-U-M, remember that's an addition problem, the sum of the measures of the two remote interior angles. So the word there is remote. So let me say the whole thing while you're writing here. This is the exterior angle theorem. So this is a theorem that's been proven to be true, an idea that's proven to be true about exterior angles on a triangle. The measure of an exterior angle of a triangle is equal to the sum of the measures of the two remote interior angles. So I've got a triangle right here, and this isn't a proof, but this is kind of like a justification and that sort of thing. I've got an angle right here that's 50 degrees, an angle that right here that's 70 degrees, and it says, can you look at the diagram and figure out why this theorem is true? And here's your hint. It's the same as yesterday. Okay, so these two angles are inside the triangle, so these are interior. So I'm going to say that those are interior. And this angle right here, this is an exterior angle. Okay, so I'm going to draw a line to that one, and I'm going to say that this is exterior. It's an exterior angle because we've kind of extended this line right here, and we've created this big angle that's outside the triangle. So that's an exterior angle. So we've got an exterior angle, and we've got two interior angles. If we weren't, didn't know about the exterior angle theorem, about the only thing that we'd be able to figure out from this is these two add up to 120. So that means this one has to make up the difference. So I'm going to do 180 minus 120 is equal to 60 degrees. So this angle right here would have to be 60 degrees. Okay, now what we'd like to do for the exterior angle theorem is come up with some relationship between this exterior angle and these two angles that are away from it. Notice that they're the angles that are not right next to the exterior angle. They're away from it. In other words, they are remote from it. So these are the remote interior angles. So this is the exterior angle, and these are the remote interior angles. Okay, so I'll get the angle symbol right there. All right, so we've got the exterior angle and the two remote interior angles. So can we say anything about the measure of this angle right here? Well, I'm going to change colors right here, and I'm going to remind you of what the hint was yesterday that we used several times. This is a straight line, and there are 180 degrees in a straight line. So if 60 of those degrees are right here, my question for you is, how many degrees are left for over here? Well, 180 altogether. I've already used 60 of them. That means this angle over here has to be 120 degrees. And where have we seen 120 degrees before? Well, 120 degrees was those two added together. So the 120 on the outside equaled that 50-degree angle right there plus that 70-degree angle right there. So if the sum of the two remote interior angles equals the exterior angle. So those are the fancy words that we use there. We're going to get used to these words and being able to identify these and stuff like that. And then we'll do a couple problems where we're actually finding the angles. So it says complete the table based on the diagram. So here's the diagram, and you'll notice that every one of the sides of the triangle have been extended to make an exterior angle. So we extended that, made that exterior angle, and then the same over here. So if the exterior angle is angle 4, so we're dealing with angle 4, so I'm going to go ahead and circle that. We want the two remote interior angles. Well, the two remote interior angles would be on the inside away from angle 4, so away from angle 1. So that's going to be 2 and that's going to be 3. So I already had 2 in the list, so I'm going to put angle 3 in that list right there. Let's see, angle 1 and angle 3. So those are the remote interior angles. So those are right here. They happen to be next to 4 and 6, so those can't be the exterior angle that we're talking about. They have to be away from that exterior angle, so that would be angle 5. So I'm going to put angle 5 right here. And then the last one says if the exterior angle is angle 6, then what are the two remote interior angles? Well, the two remote interior angles are over here. So that would be angle 1 and angle 2. All right, so if we're talking about angle 6, the two remote interior angles would be angle 1 and angle 6. Or sorry, angle 1 and angle 2. Okay, all right, let's take a look at example 2, and we actually have to find the missing angle here. So we've got this angle out here that's 120 degrees. We've got this one that's 50 degrees, and we want to find that one over there. Well, if you'll notice, this should look very, very similar. It's just tilted a little bit with a different type of diagram. So here's what I'm going to do. I'm going to take the two on the inside, and I'm going to add those together and set it equal to the one on the outside. So the two remote interior angles, we're going to add them together and set it equal to that exterior angle. So I'm going to subtract the 50, and we end up with x is equal to 70. So that angle is 70 degrees. That missing angle is 70 degrees. You'll notice that that is actually the same picture, just a different diagram there. So take a look at part B. We want to find this angle right here. That's the exterior angle. So you'll notice that the two remote interior angles are over here. So we're going to add the two remote interior angles together, and we're going to set them equal to that exterior angle. So if I add those together, let's see, 35, that's going to be a 0, carry the 1. So we end up with 130. So that missing angle is 130 degrees. That's that angle right there. I guess I'll draw an arrow to that one there. Okay. All right, so that is the idea. These are pretty easy because they just give you the angles, and you can quickly do an addition problem or subtraction problem and figure out what the answer is. Writing down the equation that's represented by that theorem is a very valuable tool, and we'll talk about that again in just a second. This one says find x, so it doesn't say find the angle, it says find x. So we definitely have to solve an equation. So you'll notice what we have here. We've got this one on the outside. These two are the remote interior angles. So here's what I'm going to do. I'm going to take the two angles on the inside. I'm going to take the 4x plus 2 and then add the 30 and set it equal to the one on the outside. All right. Now I did this in a nice way. So these numbers, these that are like terms, I put them right next to each other. So this is 4x plus 32 equals 8 plus 6x. We've got an equation with a variable on both sides, so I'm going to move the smaller one. So I'm going to move the 4x to the other side by subtracting 4x. So I might as well move the 8, so I'm going to subtract 8. So let's see, that's going to be 24 equals, this would be 2x, and then we're going to divide by 2, so we end up with x equals 12. So I'm going to circle that, and it didn't say I had to find any of the angles, it just said find x, so that is the answer. Now if you were doing this for a test or a quiz, I'd be looking for this equation right here, we'd be checking your work, and then you've got to have the right answer. So you can't just write down 12 and expect to get all the points for this. Okay, let's take a look at this one. Again, we've got this angle on the outside, and these are the two remote interior angles. So I'm going to take the two on the inside, I'm going to add those together, whoops, 22x plus 4, and I'm going to set it equal to the one on the outside, so that's going to be 120. All right, let's see what we've got here. The 15x and the 2x, those are like terms, so I can add those together. That'd be 37x. And then I've got a 5 and a 4, so that's a plus 9. And then I've got 120 right here. So let's see, if I get rid of the 9, I do a little subtraction problem, so I get 37x. This would be, let's see, 111. Yep, 111. Then we're going to divide by 37. Divide by 37. Now I think that goes in evenly, but let's just do a quick double check. So I pulled up the calculator just for some peace of mind. I got 111 divided by 37. I ended up with 3. So that does go in there evenly. So we get an answer of 3. So I'm going to write x equals 3. We're going to circle that and we're going to be done. Because again, it didn't ask for measurements of angles. It just said what is x. All right, now that we've used this a couple of times, can we put in words what the exterior angle theorem means that we do when we see a problem where we can use it? So think about for just a second, what did we do on every single one of these? We added the 2 on the inside and set it equal to the 1 on the outside. Added the 2 on the inside, set it equal to the 1 on the outside every single time. So if somebody says we're going to be using the exterior angle theorem, we could say something like this. Add the 2 angles inside and set equal to the angle outside. Now it works that way every single time, and we could be a little bit more specific. I mean, this is just a quick way to remember it. When we say the 2 angles inside, we're talking about the 2 remote interior angles, and the angle outside, it's got to be that angle that's outside, that's across from both of them. So if these are the 2 interior angles, we can't add them together and set them equal to this one. It's got to be the one that's remote from that, that's away from that, not right next to either one of those. Okay, but that's just a quick way to remember it. Most people get that. If you want to use the other words, and interior, remote, and exterior and all that, that's totally fine. So let's just quickly do this idea right here. So it says find the measure of angle FAB. So FAB. So this is noted a little bit differently. So let's figure out what they're talking about. F to A to B. They want to know what is that angle right there. Okay, what is that angle in degrees? There's our question. Okay, so if we go through and set this up the way we've talked about, well, we take the 2 angles on the inside. It'd be nice if that were a little bit closer, but I'm sure that indicates this angle B right here. We're going to take the 2 on the inside, so we're going to take 3x plus 2 plus 55, and we're going to set it equal to the 1 on the outside, that exterior angle, so 13x minus 3. So this is 3x plus 57 equals 13x minus 3. I'm going to move the 3x by subtracting 3x. I'm going to move that by adding 3. So we end up with 60 on this side, and we end up with 10x over here. So if we divide both sides by 10, then we end up with x equals 6. Now, if you circle that and say, I'm done, you're not going to get all the points. Because remember, the measure of angle FAB is equal to 13x minus 3. So let's take this and plug it in right here. So this is 13 times 6 minus 3. Let's see, 13 times 6. 13 times 10 would be 60. And then 3 times 6 would be 18. So that would be 78 minus 3. So I got 75. Let's see if the calculator confirms that. So I pulled it up on the calculator. I didn't just do 78 minus 3 because I know that's 75. I put in the entire expression, the 13x minus 3, with the 6 plugged in. So I did 13 times 6 minus 3 is 75. So we got the right answer there. So it says find that measure of that angle. So the measure of angle FAB is equal to 75 degrees. So I'm going to put a big circle around that right there, and then maybe over here I'm just going to write 75 degrees and circle that, and then everybody knows that we know what we're talking about and we did it right. All right, good luck with the assignment.